Alright class, so in our new lesson today, we're covering Cluster 5, Lesson 1, Real Numbers and Repeating Decimals. So to start off this lesson, we're going to talk about what's considered to be a real number, okay? Now, when we look at this tree diagram that we have, it breaks down real numbers, the actual real number system, into different smaller categories. Okay, so we're going to get a few definitions about this. And we're going to start with the first one. The first one we're going to cover is going to be considered to be irrational numbers. Okay, so with irrational numbers, what we're going to realize, there's a few things we have to do. What we're going to be doing with this is classifying numbers and identifying if they're irrational or rational based off some characteristics of the number. So when we're dealing with irrational numbers, the first characteristic that we have to go over is going to be that real numbers that cannot be written as simple fractions are irrational. Okay, so real numbers that cannot be written as simple fractions are considered to be irrational. Now, another characteristic of an irrational number is decimals that cannot or that do not repeat or terminate. Okay, so we're looking at basically decimals now that do not repeat, meaning they're going to have numbers, a different number every time as it goes through making a decimal. Terminate means it does not stop. Okay, that means it continues to go on and on and on, and it does not stop, and it does not repeat. Okay, so another thing that we have to remember about irrational numbers, that if we cannot classify it based off these two characteristics, then it's going to fall underneath the other category of rational. Okay, you're going to have, I've seen more rational numbers than I have irrational numbers. However, it's because it has so many different categories that a number can fall under. So the first category we're going to talk about is natural numbers. Okay, these are the numbers that you started with when you first started school, kindergarten. You started counting with these numbers. That's why they call the natural numbers, these are your counting numbers. Okay, counting numbers are the ones that begin with 1, 2, 3, 4, and so on. Okay, there's no negative numbers in natural numbers. Okay, so these are your counting numbers. These are what we call whole numbers, no decimals. Okay, so whole numbers basically are no decimals, and it starts at 1. Okay, that's what natural numbers are. They're your counting numbers. They're your numbers you learned in kindergarten. They're whole numbers. That means there are no decimals, and it starts at 1. Now, if we go up a category, the next one is going to be whole numbers itself. These are your natural numbers in 0. So a whole number includes your natural numbers. In 0. Okay, so just to give you an example, when I go to a whole number, we got 0, 1, 2, 3. So I'm going to step back to show you an example of a natural number that's nothing but 1, 2, 3, and so on. Okay, so same thing, it's just with whole numbers, it begins with 0. So anytime you see 0 in there, it follows under the category of a whole number. Okay, now the next category going up is integers. So an integer is considered to be the positive number in its opposite. So the opposite of a positive is negative. So integers are positive and negative numbers. Negative whole numbers. just to give you a simple example, -3, -2, -1, 0, 1, 2, and 3, and they can continue to go on and on, because there's an infinite many of numbers. Okay, so integers are the positive and the negative whole numbers. Now, with all those categories, the main one is rational. Okay, there's a lot of characteristics under rational. So what we got to realize is that if it's not irrational, it's definitely a rational number. So if we can identify that, then we'll be good to go. But some of the things that we look for to identify rational numbers is, the first is a ratio. Okay, if you remember anything about ratios are nothing but fractions that can be converted into whole numbers, or they stay a fraction, or they can be decimals. Okay, so it's a ratio of two integers. So it's a fraction that has two integers on it, where the denominator cannot be 0. Okay, so it's a ratio, a fraction, where the denominator cannot be 0. Another characteristic dealing with rational numbers is that they are repeating decimals. And they are also terminating decimals. Terminating means stop. Okay, so these are some of the things that we have with these definitions that we're going to have. All right, so give you some examples of rational numbers. We're talking about 3 over 1, or just 3. We can have 1/2. We can have 0.2. Okay, we can have 9 over 4. Okay, that's just a few examples of what's considered to be irrational. Now, a couple examples those are a few examples of rational. Some of the examples that we can look for dealing with irrational numbers are like the pi symbol, okay, or the square root of 2. That is the non-perfect square. Just give you an idea, or it'll give you an idea of a decimal that do not repeat or terminate, something like 0.1, 2, 3, 4, 5, 6, and so on. That decimal will never stop, but it never repeats the same number. Okay, so that's what we're talking about as far as irrational numbers. Now, looking at these definitions, we're going to look at our first example, and we're going to classify a few examples of numbers to see if we can get an understanding of what's rational or is it irrational. So when we go to the next part of our notes, let's look at what we have here. So we have -10 over 2. We got the square root of 36. We got 0 over 8, 7, square root of 140, 4 over 9, the square root of 4, -8, the square root of 8, and -2.89. So we're going to look at the first one. -10 over 2. Okay, we can simplify -10 over 2. That's going to be -5. Okay, so -5 is an integer, and because it's an integer, that means it falls under the umbrella of rational. So we can write -10 over 2 on this side. Okay, the square root of 36. So if we know our times tables, we know 6 times 6 is 36. That's exactly the same as the square root of 36. So the square root of 36 will go here. Okay, 0 divided by 8. Anything with 0 in it at the top of the fraction is 0. So 0 is what we call a whole number, and whole numbers fell under that umbrella of rational. So we can put this one here at 0 over 8. 7 is a natural number. So 7 will go here. The square root of 140. Okay, the square root of 140 is not a perfect square. Okay, we're going to talk about perfect squares later on, but by it not being a perfect square, it's irrational. Okay, then we have 4 over 9, 4 over 9. Anything that's a fraction already is rational. So that's 4 over 9. Go here. Negative 8 can be made into a fraction, so anything that can be made into a fraction is rational. So I got negative 8 here, and we have the square root of 8. The square root of 8 can go here because it's not perfect. Okay, then the last one we have in this lineup is negative 2.89. That is a decimal with the whole number, and that can be made into a fraction. Okay, now if you notice in the lineup we didn't have a lot of irrational numbers, so I'm going to give you a few more just to give you some examples. Pi. The pi symbol by itself is irrational. Okay, that is not a fraction. Pi is a number that never stops and never repeats. Okay, another number that I can think of as being irrational is like the square root of 2. Okay, now we're going to get more. We can add more to this list as we go through this lesson, but those are examples of what we consider to be rational versus irrational numbers. Okay, anything that can be made into a fraction is rational. If it cannot be made into a fraction, it is irrational. Okay, if it cannot be made into a whole number, same thing, irrational. If it is a whole number, it's rational. So we're going to practice that category and how we can put them in the right spot based off what we know in the definitions. All right, so that's that example. Just to continue on through our lesson,